Okay, so before we start understanding what is probability, we should really understand some terms associated with it. So I know it is going to be a bit boring, but trust the process, you are not going to regret it. So first let us start with what is random experiment. So it is a very important term in probability. Like if you don't understand this term, you might not like understand probability to its depth. So without any delay, let's start with this term. What is random experiment? An experiment whose all possible outcomes are known in advance, but the outcome of any specific event cannot be predicted. So it's like you know everything. Suppose a scientist is going to do an experiment and he or she knows what the outcome is going to be. Either they are going to prove a theorem or they are going to prove some statement. So they know that what is going to be the outcome. The outcome is going to be proving that statement is true or proving that theorem is true. But it is not possible for the scientists to say in advance that the outcome of that experiment would be true. It could be false also, because the scientist doesn't know. They are trying their best to prove it with the experiment. So this is what random experiment can be. I'm just explaining with an example of a scientist performing a scientific experiment. It could be any other experiment. Like it doesn't have to be that level of proper experiment. It could be like any experiment you are performing or anything, just anything. We would be taking examples, but you can just have a very loose perspective of what it could be. So this could be termed as a random experiment. Proceeding, let's see the very conventional examples of tossing a coin, throwing a dice, or an unconventional example of a batsman hitting six in an over. That could be a random experiment. Okay, so proceeding, let's understand what is sample space. So a sample space is a set of all possible outcomes of a random experiment. It is denoted by capital S, of course, because it is a set, and it is denoted by S because it's sample space. The name starts with S. A very basic thing, but set of all possible outcome. What does that means? Suppose you are tossing a coin. Suppose it's like let us say S equals to either, what could be the outcome? Either you would get head when you toss the coin, or you could get tail when you toss the coin. It is going to be either of them. So this set would be called as sample space of tossing a coin, because this could be the all possible outcomes. Like, is there anything that could be other than this? No, of course. Like if you flip a coin, you are not supposed to get a dinosaur. I mean, it's ridiculous that I can think of it, but anyways, you can't. It's very common thing. So it's basically very simple thing that it's the outcome of all possible outcomes that it could be. Okay, so proceeding. Okay, there's a note out here. An element of the sample space is called sample point. It's very important to understand. Like from the previous example, we said that if we toss a coin, we get either head or either tail. So this each element, like this element H or this element T, that is head or tail, this each element is known as sample point. Okay, it's pretty clear, I guess. Next, let us understand what is event. Event is nothing but a subset of sample space. So, like as I mentioned, suppose let us take rolling of a dice. So, if you take rolling of a dice, just a minute. If you take rolling of a dice and suppose say we are taking the sample space of the outcomes, what could be the sample space of rolling of a dice? 1, 2, what's wrong with my 2? 2, 3, 4, 5, again my 5. If we roll a dice, we could have a sample space of 1 to 6 because dice has all that could be. We can't get anything other than this. But we're talking about event, we're not talking about sample space anymore. So why I'm taking this example, I want you to explain what is event. So if we consider an event from this, we could say we want an event that is E equals to, suppose the probability of getting 3 and 4 when we roll a dice. Suppose I say that I want to talk about the event of getting 3 and 4 when we roll a dice. Okay, so that could be considered as event equals to 3 and 4. This could be our event. Okay, when we focus on certain sample points in a sample space, that is when we are talking about event. Okay, so since subset is a set also, and the set is always denoted by caps letter, and then an event would also be denoted by caps letter, that is event is denoted by E. Okay, so this, from this Venn diagram, you can really understand it clearly that if this is a sample space, then event is a subspace of sample space, of course. Okay, then next comes event is of two types, that is simple event and compound event. What is simple event? And simple event is, this won't be and, I guess this would be an, please consider it. Anyways, so an event containing exactly one simple point is called elementary event or simple event. So simple event is also known as elementary event. So the example of rolling of a dice, then event equals to, suppose I want to get 6, I'm bothered only getting 6. This is going to be a simple event, right? Because it has one sample point. I mentioned earlier what was sample point, because it has only one sample point. But if I'm talking about a compound event, the event equals to rolling of a dice, the event equals to, suppose I want to get 3 and 4. I'm bothered about getting 3 and 4. So that could be a compound event. Okay, because we are not talking about one sample point at a time. We're talking about more than one sample point. And if we go with the definition, the event which can be decomposed into simple events, like as I mentioned 3 and 4, it could be decomposed into a simple event, like I can only talk about getting a 3 or getting a 4. Okay, so decomposed into simple events, that is which can be expressed as union of two or more simple events, which is called compound event. Again, this would be T. I'm really sorry for the spelling mistakes. I don't know, I think it's a typo error or something. I just overlooked it. Anyways, so proceeding. Exhaustive event. Okay, this is now where the game actually begins. Like, you are literally getting into the core terms of probability. Like, please understand, this is very important. Exhaustive events. So what is exhaustive events? You're going to hear it over and over in the period of time, no matter like you're dealing with probability or you're dealing with statistic or not. Like, this is very important term, please hear it out. Take all your attention here. Okay, so exhaustive events is two or more events. Again, I don't know what is wrong with this even and events. This is going to be T. Okay, please consider it. Anyways, two or more events such said to be exhaustive if at least one of them necessarily occurs, or in other words, the events A1 union A2 union A3 equals to S, that is sample space. So it's like there would be a necessary of occurrence of either of the events. Suppose we are talking about A1, A2, A3, these are the events. Suppose these are a kind of events, and there's a necessity that either of them would occur. It cannot be that A1 is also not occurring, A2 is also not occurring, A3 is also not occurring. No, this cannot be the case, where either any of the event have to necessarily occur. And in other words, what could be an exhaustive events? If all the events union gives the sample space. We will like consider a very good example which would like very easily make you understand. So here's the example. Okay, suppose there's a X limited company whose share price goes up. So At a time, its share price can go up, and at a time, its share price can go down, or it doesn't changes. Don't tell me that like three of them could happen. Is it possible at a time that a share price goes up, a share price goes down, and a share price doesn't changes? No, it is not possible. So either of the three have to happen. Like either the share price has to increase, or it has to decrease, or it has to be constant. Like either of them have to happen. It is necessary. If a market opens, then this is something that has to occur. Okay, and again, if we consider a union of all these things, it would give the sample space of an stock price given on a day. Like this could all that be happen. Okay, nothing else cannot, like all these things, if we take union of it, it would give us the sample space. There's no other way you can like talk about this. Please tell me in the comments if you don't agree with this, but I think you have no other way instead of agreeing this. Okay, so I think exhaustive events is really clear with this example. A very I like to come up with like non-conventional examples so that understanding becomes clear, because it's very boring talking about those same conventional examples in every class. Like, I hope you understand me. Okay, so proceeding, okay, this is very, 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 very important term. Mutually exclusive or disjoint. Like, especially we use mutually exclusive term only. We barely use disjoint even. But be aware of the term, because in question or anyone talking in general can mention disjoint event instead of mentioning mutually exclusive event. So what is mutually exclusive event? If two events A1 and A2 have no common sample points, that is, if A1 intersection, this intersection, please mention it, I mean, please consider it, A1 intersection A2 equals to null, which means it has no common points. Like if you do intersection of these two, A1 and A2, this would be null, like nothing would be there. Okay, then event A1 and A2 are called mutually exclusive events. It is very simple. It would be very clear when I take the examples. For now, just understand this: when two events will have no common points between them, or no common sample points between them. Okay, note this point: two mutually exclusive events cannot occur simultaneously. Two mutually exclusive events cannot occur simultaneously. Okay, things are getting very confused out here. Let me take an example to make it simpler. Okay, same the stock example, but this time it is not going to be that complicated. So, in a given time, a stock price can either go up or either go down. Is there any way that at a given point of time, the stock price can go both up and both down? I'm not considering the stock price being constant, please. In this case, I'm not considering that. I'm talking about, is there any possibility that at a given time the stock price goes up and the stock price goes down? I have never seen it happen, and I hope you have never seen it happen, and it could not happen actually. It is ridiculous to even think about. So these two events of a stock price going up and a stock price going down could be called as a mutually exclusive event, because this, if we do intersection of it, we will get null, because there's no possibility of this happening, both of this happening at the same time, which also like satisfies the statement very, very, very clearly that two mutually exclusive events cannot occur simultaneously. That means a stock price cannot go up and go down at the very same time. Okay, okay, we are here with the last slide of the day. It is very, very important statement. Okay, every set of mutually exclusive events can be exhaustive. Every set of mutually exclusive events can be exhaustive if they cover, not the cover. Okay, every set of mutually exclusive events can be exhaustive if they cover all possible outcomes. However, Not all exhaustive set of events are mutually exclusive. It really boils down to a very simple statement that all mutually exclusive event can be exhaustive event, but all exhaustive events, however, cannot be mutually exclusive event. It may not be necessarily be an exclusive event. Okay, so this is an important statement. Please keep in mind. Also consider this would be they, not the. Okay, so that's all for the day. I hope my understanding was pretty clear. Thank you for watching.